All right, the lesson for this week is the difference of two squares and the quadratic pattern. So remember, when we have a quadratic pattern, okay, we need to be in standard form. And we're going to be using the X method to factor, okay? So I'm going to go over this packet with you. First of all, go ahead and change that due date from March 30th, if it hasn't been changed on yours, to April 3rd. That's the following Monday. Okay, so let's go ahead and take a look at this first example. So right off the bat, we have this equation. What we want to do is we want to factor it, okay? And then we want to find the x-intercepts. So some notes over here. Notice that both coefficients, notice I have a little arrow here, the coefficient, that's this number, and this number are perfect squares. Remember your perfect square sheet that we made? 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So if you still have that yellow sheet in your notebook, which you should, please get it out because you're going to need it to do this assignment. Okay, so the second thing we're looking for is the difference. Difference means subtraction, not addition. So notice we have a subtraction. So we have a difference of two perfect squares. No b value. Okay, so the b value is missing. So in standard form, okay, the b value is missing. And so we're going to have ax squared minus c. Now, what we're looking at here is a special circumstance, okay, for factoring. So if the b value is missing, and these are perfect squares, okay, then we're going to have something that's called the difference of two squares. So now everything is written out for you, but I'm going to go ahead and go through this problem using my success criteria. So here's our problem. So the first thing you should notice is it's quadratic, okay? It's a difference, so it's subtraction of two perfect squares. 2 times 2 is 4, x times x is x squared, 3 times 3 is 9. So we have a difference of two squares, okay? First thing we want to do, as you guys already know, is we want to set the equation equal to 0. Done. That's criteria number 2. Factor out the greatest common factor. Well, if you look at 4, the factors of 4 are 1 and 4 and 2 and 2. If you look at the factors of 9, you get 1 and 9 and 3 and 3. Now we don't count 1, but notice they do not have any common factors other than 1. So we cannot factor out any number out of these two numbers. Next, use the X factor method. Okay, so we're going to do A is 4, B is missing, so that's going to be 0, and C is negative 9. Okay, multiplying A times C on the top, the B value goes on the bottom, and it's going to simply always be a number times its opposite, because when you add them together, you get 0. When you multiply them, you get negative 36. So for example, if this was negative 25, it'd be 5 times negative 5. Okay, let's put the A value on top. Okay, reduce, we get 2/3, and we get 2 over negative 3. Reducing those two fractions. Okay, step number 4, we want to write the factors. So here we have 2x plus 3, and here we have 2x minus 3. remember the sign always stays in the denominator. And if this ever divides out to be a whole number or an integer, make sure you put it over 1. Okay, so last step, finding the x-intercepts. We set each factor equal to 0. And we solve for x. I'm doing adding and subtracting first. Undo multiplication with division. And this is going to be our first x-intercept. Sorry about that. Okay, solving for the next one. And this is our second x-intercept. Okay, so on this paper that was created by the Algebra 2 team, there is a second method that you can look at and read over. I highly recommend that you stick with this first method. Okay? All right, let's look at another example. Actually, before we do, look at the back of the first page. It says, what if the problem has a greatest common factor or the coefficients are not perfect squares? So notice that these two numbers are not perfect squares, but they have a greatest common factor. The factors of 3 are 1 and 3. Factors of 12, 3 and 4. Now I know there's more, but notice they have a common factor. And remember what I told you. Factoring means to divide. So what we did here is we divided everything by 3. So 3 divided by 3 is 1. And then minus 12 divided by 3 is 4. And 0 divided by 3 would be 0. Now, when we look at our new equation, okay, we now have a perfect square, 1, and another perfect square, which is 4. So now we could do the x, and we can factor this out. Okay, so that's one thing to keep in mind. Okay, next one. What if the problem doesn't equal 0? So notice here it doesn't equal 0. Well, you guys know how to handle this. We're going to make it equal to 0 by canceling out the numbers over here on the right. So canceling out the 25, and then we have 49x squared minus 25. Then we have perfect squares, and then here's our factors. Okay, so let's go ahead and, one more example, guys. What if the problem is addition? If it's addition, then it's not factorable, okay? It's not factorable, and there's no real solutions, okay? They're not real, they're imaginary. All right, let me choose a problem, another problem, and we'll walk through it together using my success criteria. Okay, let's take a look at this problem. Now, this is number 10 on your practice, okay? So remember, the success criteria is to set equal to 0. So we're going to cancel out the 64 and move it over to the other side. Remember, you can pause the video at any time, rewind, etc. Okay, now if we look at these, we're looking to see if they're perfect squares. Well, first of all, it says for number 2, we want to factor out the greatest common factor if possible, which means we need to write down all the factors of these these two numbers. So on your calculator, and remember you can download the TI calculator, Inspire calculator, using the link that I posted in Google Classroom. But let me remind you, so the factors of 484, if you go to the graph screen and you type 484 divided by x, okay, and then we press enter, and we press Control T, and then here we have a list of all the factors. So 1 and 484, 2 and 224, 4 and 121. You should write them all down. Looking for the next one. The next one's 11 and 44. And 22 and 22. Okay, so going back, I've written them all down right here. So here's all the factors of 484. Here's the factors of 64. Which one is common? The largest one, remember we don't count 1, so it's going to be 4. So that's what we're going to do. We're going to factor out a 4 out of these. So we're going to divide everything by 4. And as you can see right here, 4 times 121 is 484. So that's going to be 121. 64 divided by 4 is going to be 16. And notice we have two perfect squares. This one is 11 times 11. This one is 4 times 4. Now, we can now draw our x, and we can multiply these together and put a 0 down here. So here's my suggestion. Here's a shortcut. Okay, these are some pretty big numbers. Even though we factored out the 4 and we made these numbers smaller, they're still pretty big numbers. But what you can do here, a little shortcut, is what number makes 121? Well, 11 does. So we put 11 here and 11 here. Okay, splitting up the x. And then the 16 is 4 and 4. Okay, one's going to be positive, one's going to be negative. We did this in class, so hopefully this rings a bell. And now that we have our factors, good job, we're going to go ahead and find the x-intercepts. So we set each factor equal to 0, and we're going to solve. Subtract the 4, divide by the 11. Add the 4 on both sides, divide by 11. And so there's one x-intercept, and there's the other one. So I hope this all makes sense to you, because this is a review. I know we did it together in class. You probably have some notes in your notebook you can look at. So please make sure that you do these problems. Again, this is number 10 on the practice. You have one less problem to do. And there will be a quiz sent out later this week for you to also turn in. Hope you guys are all well.